Welcome to SynSquad Innovations, where the future of enterprise solutions is not just imagined but brought to life. Join us on a journey through the minds and the architecture that drive our innovation. Mbuza Mobina, the plant in our garden of innovation, sows the seeds of creativity in our business architecture, ensuring that our foundation is as robust as it is ingenious. Mpilable Ntumbila, the resource investigator, delves into the depths of our information architecture, unearthing data gems that propel us forward. Thabiso Molif, the finisher who harmonizes and refines our application architecture, making sure that every service we book is a testament to perfection. Quentin Maffa, the team worker who strengthens the backbone of our technology architecture, merging code with collaboration. Zandi Mathabella, our coordinator and specialist, is the compass that guides our strategic security measures, guarding the gates of our digital fortress. Kwezi Kulwini, the implementer, ensures that the GPS of our operations within the technology architecture leads us to our desired destination every time. The business architecture is the strategic map of SynSquad. Here, we chart the journey from our core values to our towering aspirations, ensuring every stakeholder is a participant in our story of success. Our application architecture is the digital heartbeat of SynSquad. It's where user profiles are born, trips are planned, and the wheels of innovation spin endlessly to deliver exceptional service. Information architecture is our library of Alexandria, a reservoir of knowledge. Here, data from every corner of our operations is collected, cleansed, and transformed into actionable intelligence. Technology architecture is our workshop, where tools and platforms are wielded with precision. From cloud computing to serverless environments, we sculpt the digital landscape of tomorrow. In the domain of security architecture, we stand as sentinels. Multi-factor authentication, encrypted databases, and rigorous access controls are the shields that protect the sanctity of our data. Together, we are SynSquad Innovations, architects of the digital domain, champions of security, and pioneers of the information age. Join us, and let's innovate the future.
Today, we're diving into the transformative world of mobility as a service, or MaaS, and how it's reshaping transportation in developing countries. Let's explore the enterprise architecture that makes MaaS not just a concept, but a reality for improved urban mobility. MaaS integrates different modes of transportation into a unified service, all accessible through a digital platform. It aims to revolutionize urban transport by offering a convenient, seamless mobility experience. This is especially pivotal for developing countries where infrastructure and transportation services face many challenges. In the business architecture section, we'll identify stakeholders like government authorities, customers, and investors. We'll then map out key processes that make MaaS work, such as user journey mapping, service provider integration, and payment processing. Next, we'll break down the information architecture. This includes the data warehouse, where historical data is stored, data governance practices ensuring security and privacy, and the use of data marts for efficient information access. Our focus will then shift to the application architecture. We will discuss how a user-friendly interface is crucial for trip planning and service booking, and how back-end systems support these functions through APIs and integrated payment systems. We'll also touch on the technology architecture that underpins MaaS, highlighting the importance of cloud computing and serverless architectures. Then we'll address the security architecture, ensuring user data and transactions are safeguarded. We'll wrap up with the benefits and potential of MaaS for developing countries, looking at how this platform can offer efficient, sustainable transportation alternatives, ultimately improving the quality of urban life.
This diagram presents a high-level enterprise architecture for mobility as a service. It further details various aspects such as the IT services, the business, technology, security, application, and information architectures, and the IT infrastructure components. Now, the architecture aims to enhance transport operations, improve customer satisfaction, ensure data security and privacy, and comply with regulatory requirements while focusing on cost effectiveness, reliability, flexibility, and convenience. Now, let us look further into this diagram.
Let us look at the business architecture. The top of this diagram identifies the key stakeholders that we would expect in the transportation industry. These would be government authorities, customer or passengers, suppliers, transport operators, and furthermore. Moving on, from the stakeholders, we have identified the business processes, which include the business workflow, business objectives, value proposition, risk management, and further key business processes. The information architecture is a detailed diagram for a data-driven system or organization. This diagram is divided into four main components. We have data providers. This area of the diagram represents the sources of data entering the system. Government DB, indicating a database that might contain public sector information relevant to the business. Real-time data. This suggests that the system is receiving data continuously in real time, which is critical for up-to-date analytics and operations. Moving on to the data warehouse. The data warehouse, which is a large store of data accumulated from a wide range of sources within a company and used to guide management decisions. It includes historical data storage. This is where historical data is stored, which can be used for analysis over time to detect trends. Metadata management. This involves the handling of data about other data, which can include data type descriptions, relationships between data, and other characteristics essential for effective data management. Data cleaning or transformation. This step is critical to ensure the quality and usefulness of data by removing inaccuracies, duplicates, or irrelevant information. To the right of data providers, there is a data mart section, which is the subsection of the larger data warehouse. A data mart is a subject-oriented database that is optimized for access to data needed by a particular group or department. This section includes driver info, vehicle information. This would include data specifically about the drivers and their vehicles, perhaps including details about vehicle status, driver schedules, and etc. User information, referring to data about customers or users, like profiles, preferences, or usage patterns. Trip details, likely involves data about the trips booked, including routes, timings, and so on. And finally we have booking AMP, transaction. This would track booking details and financial transactions related to the services provided. Data governance, which is the overall management of the availability, usability, integrity, and security of the data used in an organization. This section emphasizes data security AMP, privacy, highlighting the importance of protecting data from unauthorized access and ensuring that personal data is handled in compliance with privacy laws. Compliance AMP, regulations report. The system must adhere to certain standards and legal requirements, and reporting on compliance is a critical activity. The whole architecture is interconnected, indicating the flow of data from external and internal sources into a centralized data warehouse where it's cleaned and transformed, then distributed to specific data marts for various business needs, all within a framework of data governance that ensures security and compliance. This setup is typical for organizations that rely heavily on data for their operations, such as those in transportation, logistics, finance, or e-commerce. The security architecture is divided into four components. Authentication, MFA. Multi-factor authentication. Single sign-on. Secure communication portal. Transport layer security. Secure socket layer. Data encryption. Cloud storage. Data in transit. Authorization AMP, access control. Multi-factor authentication. Single sign-on. Role-based access control. Attribute-based access control. Each component is a critical aspect of ensuring secure information technology systems. They work together to authenticate users, secure data transmission, encrypt sensitive data, and control access based on user roles and attributes. Technology architecture is a schematic representation of the technology stack, platforms, and infrastructure components used by an organization for their digital operations. Here's a detailed breakdown. Technology stacks. This is represented in the circular flow diagram and describes the different technologies used in the software development lifecycle. OAuth 2.0, JWT, these are standards for authorization and tokens used for secure user authentication. RESTful APIs, application programming interfaces designed according to the principles of representational state transfer, commonly used for web services. Payment gateway APIs, interfaces specifically for integrating payment services, allowing the application to process financial transactions. PostgreSQL, MongoDB, these are databases. PostgreSQL is a relational database, while MongoDB is a NoSQL database used for storing data. React.js, Angular, These are JavaScript frameworks used for building user interfaces, particularly single-page applications. Node.js, Python/Django, Java, Swift, these are programming languages and frameworks used for server-side development. Platforms. To the right of the technology stacks, the Platforms section refers to the services and tools used for deploying and running applications. Cloud computing, Microsoft Azure, a cloud computing service for building, testing, deploying, and managing applications and services through Microsoft Managed Data Centers. C/CD pipelines stands for Continuous Integration/Continuous Deployment, a method to frequently deliver apps to customers by introducing automation into the stages of app development. Docker and Kubernetes. Docker is a platform used for developing, shipping, and running applications inside containers, while Kubernetes is an open-source platform for managing containerized workloads and services. Infrastructure components.
Below the Platforms section, Infrastructure Components details the physical and software elements that support the technology stack and platforms. Physical/virtual servers, the hardware or virtualized servers where applications and services run. Routers, switches, firewall, networking hardware that controls the flow of data across the network and provides security. Storage, area networks, SAN, dedicated network storage solutions that provide access to consolidated, block-level storage. The arrows between the different sections indicate interaction and integration among the different components of the architecture. Deployment arrows from the Platforms section suggest that applications developed with the technology stacks are deployed on cloud platforms using C/CD pipelines, with Docker and Kubernetes facilitating the deployment, scaling, and operations of these applications. The application architecture is structured into different layers and components that interact with each other to provide a cohesive user experience and back-end processing capability. Presentation layer. This layer is likely the user interface of the application where users interact directly with the application. It includes Create User Profile, Book Service, Plan/View Trip, Types of Transportation, Front-End Applications. To the right of the presentation layer, front-end applications are mentioned, which likely refers to the applications that users interact with directly on their devices. It is connected to back-end systems and APIs AMP, integration. Furthermore, user registration, location, select transport type, plan trip AMP, book service. This describes the process flow that a user would go through when using the application. Fare comparison system, a feature that allows users to compare fares, possibly across different types of transportation or service providers. Integrated payment processing system, this would handle all transactions, ensuring secure payment for services booked through the application. Enterprise resource planning. At the bottom of the diagram is enterprise resource planning. This is typically a type of software that large organizations use to manage day-to-day business activities such as accounting, procurement, project management, risk management and compliance, and supply chain operations. This indicates that the application feeds into or is integrated with a broader ERP system for the business, allowing for real-time data flow between the application and the core business operations. The arrows indicate the flow of information and interaction between the different components of the architecture, showing that data moves from the front end where the user interacts with the application, through the back-end systems and APIs, and ultimately into the wider enterprise system of the organization. This architecture is typical for modern, scalable, and integrated digital platforms.